I can see some of them are waiting. So, good evening, everyone. So, before getting this is the first time I'm coming live over here. So, please respond me through the chat box. I'll be active in the chat box. So, good evening, all my viewers. So, let me know that am I audible to all of you? Am I audible? Just can you, whoever my viewers right now, just you can use the chat box because the purpose of this video is to lively interact. Good evening, everyone. Good evening, Chandan. Yes, I'm audible. Right. So today here we are going to discuss about aerodynamics. Okay. So which is one of the very core part of your syllabus in Gate Aerospace 2022. Okay. So today we will mostly discuss that where you can make the possible, in the last moment, you might think there is a syllabus is quite vast. So what are the particular area you can focus on? So the main agenda is going to be the area you're going to focus on it. Fine. Now, before starting that, as you know, this graduate aptitude test in engineering, it has various parts and all those things are there. But here we are going to focus on this aerodynamics part. So, talking about this basic aerodynamics, is my screen visible? Additionally, is my screen visible to all of you? Is visible? So, just write in the chat box. Kishore, Chandan. So side by side, whatever the important uh, things we are discussing, so you can write it down, right? So the major agenda of today's is to discuss about aerodyna, sorry, dynamics. Okay. So basically, this, as per your syllabus is concerned, it has been subdivided in 5 parts. Okay. First part is your basic fluid mechanics. Okay. Second part, you have airfoils and wings. Third part, you have about viscous flow, and which is combined with another the subpart which is a compressible flow, and the last one is a techniques. Lot many testing techniques. Like one of them is a wind tunnel techniques. Now, among this, when we talk about this aerodynamics, so this is a particular subject which is a quite interconnected with the propulsion. But here we'll have another session with the propulsion. So there we will discuss how the things are connected. Because one thing you have to keep in mind that in a gate exam is concerned, as for the gate exam is concerned, you have to prepare your questions or plan your studies like how you can connect the aerodynamics with the propulsion and other subjects, right? Now there are something like stability questions are consuming time while doing mock test exams. So how can we time strategy, right? See, there are some things which are there that you have to balance the thing, right? So you have to, time management, obviously time managements are there. The only thing which we delay is that we have to practice a lot, then only the formulas is going to be on your fingertips. Formulas are going to be on your fingertips. Kishore, I hope I made you clear. Just okay. So can I carry forward? Right? Now next we have our that's coming back like how you can prepare yourself. Like, and this is, let me tell you, this particular topic is a very important one. This is one of the important, or is a, you can say it's a core of it, core of or heart of this aerodynamics, where first of all you have to understand what are the different types of fluid flow. You must be aware of what is stream function. I mean to say, what is stream function in the sense like how the stream function and velocity function. The stream function mathematically defined as psi, sorry, right? Psi, and this is pi. So when these two things can be used, you have to be very much alert about these two things, and these two are one of the very important parameter which defines the flow. So if they ask like when we can use this function, you remember that if it is something with a relevant to 2D flow, we have to use the psi, that is a stream function. And where it's something relevant to 3D flow, three dimensional flow, where we have some function of x, y, and z, we have to use the phi function. And when and using these functions, we can also relate the type of flow. Whether when we talk about the type of flow means whether it is a steady flow or unsteady flow, whether it is a uniform flow or non-uniform flow, whether it is laminar, we cannot judge this with the laminar, so we can keep those things apart. Whether it's a rotational or incompressible flow. Okay, rotational or irrotational or the compressible or the incompressible flow. We can find out the characteristics of the flow using this psi function and the velocity potential function. This is one of the very important when the gate exam is concerned. So you have to remember the basic formula. They have a simplified version of formulas. So you have to, if there may be some equation like this, like v equals to ui, sorry, 2x I, there may be equation like this, v equals to 2xi minus 2yj. They have given this equation and they asked that identify the flow, whether it is be rotational compressible or rotational incompressible, like lot many varieties are there. So there are ways to find out using v equals to ui plus vj is a basic standard formula. So you know what is u? U is a velocity component along the x direction, which is 2x, and v is an velocity component along the y direction, is minus 2y. Right? Now, how we can identify this? So there are a lot many ways. One is a function of wz. One is a way is a to find the wz, that is a angular velocity. So, and if the angular velocity along the z direction should be 0. If it is 0, that means that flow is irrotational. And what is a formula to find? Half dou v by dou y, sorry, dou x minus dou u by dou y. Alternative fashion it will be. And once you differentiate, partially differentiate it with respect to these parameters, if it satisfies to 0, then obviously it's going to be proved to be as an irrotational. And when we can say this particular same equation whether it's a compressible or incompressible. So we have to use a continuity equation. So it is dou u by dou x plus dou v by dou y plus dou w by dou z. It has to be 0. So these are certain strategies that this is how you can figure out those things. Is it clear? So you can write in the chat box side by side simultaneously. You can engage that. So first we have discussed this basic fluid mechanics which play a very vital role, right? So there are another possibilities of questions, and this is definitely will get one other question from this particular topic, that is basic fluid mechanics. There are another types, like they will give you one equation like psi function is 2xy. They have given this, and they will ask if the how you're going to convert the psi function into phi function. Okay, so what will be the phi function? So there are ways. So again, there is a unique relation between psi function and phi function. So using that particular thing, this is one of the very much scoring. Then how the viscosity, two types of viscosities are there: dynamic viscosity, kinematic viscosity. So how this dynamic viscosity and kinematic viscosity are related with one another. Okay, so what is a unit? Yes, here very much important is the unit, right? So Newton second per meter square. Sometimes in the question, you may also face that challenges about the viscosity. They might have given that viscosity and the unit is meter square per second. So if they said if you have a unit like meter square per second, that means they have given you the kinematic viscosity. There are a lot many questions you can find in a gate examination. They have not clearly mentioned what the parameter is. Sometimes you need to identify the parameter by looking at the units alone. By looking at the units alone, you can able to identify it. Clear? So side by side, I'm looking for the responses. If you have any other question, you can drop that of particular topic. If you are facing any challenges, so you can side by side write that. Okay. Now this topic which I've discussed right now, it's one of the very important topic. Definitely you will find one or the other question from this particular topic. Right. Now moving forward to the next, like side by side, there is another topic, like next topic is a your airfoils and wings. In airfoils, before starting with the airfoils and wings, there are certain theorems that you have to remember. For an example, there are the combinations of flow, like source flow, sink flow, doublet flow, line vortex, and superimpositions of those flows, right? So this is again play a very important role. So here you have to remember the equations, like for stream function, for maybe for like if you talk about uniform flow, so what is going to be the stream function for uniform flow, what is going to be a stream function for sorry, velocity function for an your uniform flow. And very importantly, definitely you need to remember this chart which I'll be sharing here. The chart where you have to, which you can also find it out. I hope it's visible to all my viewers. So this a small table will help you sometimes, maybe for solving problem. So you can keep some tips and tricks to remember this particular chart. Okay, you can remember this particular chart to remember how you can remember this thing. So definitely again one more problem or some kind of you know we can say relevant questions can come, and there may be possibilities like they will give you one of the parameters you have to find the unknown one. And for this each and combination of flow, right, when we combine uniform flow, source flow, vortex flow, right, combination of uniform source and doublets, what will be the result of that flow, right? So this kind of questions you just prepare accordingly, right? Now, next, talking about the basic flow, we are still stuck on the basic flow, and there are most probably around 5 questions we'll be getting from this particular topic, right? So, basic fluids, the properties of fluids are obviously important, but in addition, like Bernoulli's equation, the applications of Bernoulli's equation. So, and which is one of the example we can say low speed wind tunnel. Okay, low speed wind tunnel. So what are the parts and what are the formula? So here I'm going to share that as well. This is again which is a relevant topic with our this unit with the last unit. Okay, which is going to be another relevant topic with the Bernoulli's equation. I hope this visible along with the parts which I have mentioned in the screen. Is my things visible? All right. So here you can see some basic parts. So there are a lot many questions can arise from this. So first of all, like what principle it lies behind it. So we can say one of the combination of Bernoulli's principle, right, and your continuity equations. Okay, Bernoulli's principle and continuity equation. So this is one of the very important topic. So there are possibility kind questions can appear from here. This is again definitely 1 to 2 marks questions, 1 to 4, right? Out of 100, 2 to 4 marks can generate from this wind tunnel, such low speed wind tunnel, and which is one of the important topic. One of the question can be like what are the different components sequentially, how they're aligned. Next, like if I have a ratio between A1 by A2, how can I relate them? Whether they are going to greater than 1 or greater than 2 or less than 1 or equal to 1, how they are related. So first of all, one thing you have to keep in mind, by seeing the image itself, you can figure it out. The entrance is always A1, and when the flow is entering into the test section, it is the section A2. So this is A2. So obviously the section A2 is less as compared with A1. So the A1 by A2 ratio is always going to be greater than 1. So if there is a question like application based, what should be the approximate ratio? It should be always 8 to 15. There may be a possibility to get some questions relevant to application based. So it is going to be like your always has to be more than 1 or close to your 8 to 15. Or if there are some approximate value, like you can roughly say 12 to 12 to 13, in fact, right? Now, similar type of confusing questions can appear, right? So, if they give this is also section 3 and this is 4, for an example, if they have given like that. So, remember, this is a portion of a test section. This is the portion of a test section. So, A2 is always equal to A3. A2 is always equals to A3, right? Because there is no fluctuation of area. It's going to be constant over here. Now the next is, if it is this portion is a section 4, so again this A4 is greater than A3. Now what will be the ratio here again if such kind of question comes? So A4 by A3 has to be close to 2 to 4. Okay, not more than that. It has to be close to 2 to 4. These are the standard rule, or you can say. And coming again to some of the again basic flows, what will happen with the flow parameters if I consider the velocity and pressure, right? So as this is a subsonic flow means Mach number less than 1. So there may be there one year they have asked a question like there is a flow like from the subsonic to supersonic, what should be the shape? Like they have not clearly mentioned about the shape, so you have to identify what is going to be the suitability of the structures, right? So or the cross section. So let's have a look on A to 2. That means section 1 and 2. So we can say it is an convergent type. It is an convergent type. And if any section we have an converging type, any section, and the flow enters is like, and if the flow enters is Mach less than 1, right? If the flow enters in the section 1 is less than 1, what is going to be the Mach 2, right? Whether as compared with the Mach 1 is it will increase or decrease. There may be some kind of this sort of questions might come, right? Whether it will increase or decrease, right? So this is again another very important, so you have to be clear with the shapes. Like basically we can say convergent type, divergent type, then combination of convergent and divergent type. Now in this three basic shapes we can classify them in the subsonic and supersonic as per your syllabus is concerned. So for inlet flow and the exit flow for different conditions, you have to be clear. Definitely another kind of questions will be coming up from this particular thing. Okay, now there may be some questions sometimes they ask in the gate like reason based question, like they say that if we are using like divergent type section, suppose they any particular like let's take an rocket. Okay, rocket we use the exit part, we have the divergent type. Or the question comes like why most of the rocket engine when it flies more than Mach 1, it can be it can be supersonic, it can be hypersonic, why we prefer to use a divergent type, right? Why do we prefer to use a divergent type? There may be this kind of question. So let's have something interactions, like I would like to see how many of you respond to this chat. Like you can give a simple answer, why do we prefer a divergent type in a rocket engine, why not a convergent type? There may be some reasons behind it, right? Obviously might be some reason behind it why we use so. So I'm looking forward some answer in the chat box. And behind this, there is something aerodynamics is related behind this answer. Um, you can say if you're not sure, you can just write no. It will be completely fine. I will discuss about it. Anyone, you can just check it. The question is why we use divergence section in an aircraft in a rocket engine. But whereas if you compare in a jet engine, we are not using a divergence section. We use a convergence section. Why so? So one of the answer I got in the chat box is in any other question answer did I get? Any other? Okay. So fine. One is one of the very right answer is area relation, right? So as at the area relation, there is a one is a Mach number, and second is that we are talking about the pressure relation. So if when it is a divergence section, and the Mach number is greater than one, right? What happens? The suppose here we have Mach 1, here we have Mach 2. So obviously in this divergence section, when the area is enlarged as compared with the section 1, the Mach number increases. There are one more reason which leads to further increase and produce thrust. The reason behind is an shock waves. Now there are again further different types of shock waves. Basically we have four types of shock waves. One is a bow shock wave, then oblique shock wave, expansion shock wave, and we have also a normal shock wave, right? Now there may be a possibility that in a gate exam they will give you some shape, and they will give you some region like one belt here, one belt here, one, two, and some three. They will ask you that what are the places, what kind of shocks will be produced. Okay, and they might give you some angle of attack of something, and what angle it is inclined, at what angle it is inclined it. So all those parameters they might give you. They will just ask you at the point 1, 2, 3, 4 or whatever it is, what are the different types of shock wave will form. So you should have a clear understanding for your bow shock wave, oblique shock wave, expansion shock wave, and the normal shock wave, right? Clear, eh? Then this is again very 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 important topic. This talking about the shock wave. Now, let me see whether any other topic we have skipped from the basic mechanics. Yes, there is one more relevant topic which we have to discuss is a dimensionless parameter. We will come to the shock wave when we will discuss the third, third and fourth part. Okay, when we'll come to this viscous flow and compressible flow, again we will come back to this shock wave part. Okay, we'll come back to this shock wave. Now, first, let us complete this our basic, that is diamond is dimensional analysis. This is again another very scoring and very important as per the gate question is concerned. Again, you will get some questions from 2 to 4 marks from this particular topic, right? And if there may be a possibility of uh, numerical aptitude test where you have no negative marking, right? And if you answer it carefully, definitely you will get full marks. And most of the this numerical aptitude question or the this kind of thing, you have two. It carries 2 marks, and you have to be very careful. One more with the parameter is round off to how much decimal place. Whether they ask round off to integers, either they can ask round off to integers or round off to decimal, right? So, and what is a place of decimal? Because the answers, everything are going to be checked through the computer. Even you have checked correctly, so even you have you have to solve correctly, but still you will have a wrong answer if you have missed something. Like for an example, there is one numerical, like having two decimal places, and you got the answer 4, and if you're just typing 4, still the answer is right, it will be wrong. But if in the two decimal places, that point zero zero, right, then your answer is right. Because computer, if you're not putting dot zero zero, it will consider as wrong, though you have solved it correctly. And same thing, if they ask round off to integers, so that time you should not keep 4, you got an answer 4.75, either you write 4 or 5, right? So that these are the things you have to keep in mind, this round of the integers part, right? Now coming back to this dimensional analysis, I think I got some question. um right. Ma'am, velocity triangle can come. Yes, we will discuss about the velocity triangle when we will discuss about the propulsion. Definitely this is one of the important topic. Okay. And another question, four questions from fluid mechanics involve buoyancy, momentum flux. No, this as per the syllabus is concerned, buoyancy is not in our syllabus actually. In the new syllabus, buoyancy force is not there, right? Buoyancy. And momentum flux is nothing. It's like a momentum per unit area, right? So momentum theory, already that what we are telling, Navier-Stokes equations, right? Or discharge, mass flow rate, all those comes under the momentum. Whenever the pressure forces, body forces are involved, so there we cannot say precisely that this kind of thing relevant to that obviously will be there. No, then definitely they will give some additional marks for it. Buoyancy is not in the syllabus. Definitely, I'm sure. I have my syllabus in front of me. I cannot see buoyancy in the syllabus. Okay. Don't get confused with engineering mechanics, because engineering mechanics syllabus is completely different. Uh, I don't think it is asked. If you are, I have not seen any question like buoyancy, right? Okay, we'll have discussions, some more discussions. So coming back to dimensional analysis. So first of all, the first thing which it has to understand is a dimensional homogeneity. Okay. So there may be a questions form, that means either by compiling the left hand side with the right hand side, it has to be equal, or maybe they have given some relations, like they might give Reynolds number, they might give density, they might give diameter, velocity, then you have dynamic viscosity, and they might ask how these things are related with one another, or they might give like E equals to some constant, rho power A, D power B, V power C, mu power D. What will be the power of A? What should be the power of B? What should the power of C? And what should the power of D? So likewise, there are a lot many varieties of questions they might give, right? So you should be able to pick this. And in addition, there are important five laws, that is Reynolds number law, we have Euler's law, Weber's law, then we have Mach law, right? This Froude law. Five important laws are there, and how they are significant with one another. So mostly the question comes from the Reynolds number law, okay, where it relates with the viscosity, where we have some relation with the viscosity. Now, Faraday law is a law where we need something with the forces, deals with the forces, maybe gravitational forces, right? Then coming back to Euler's law, right, where we have some pressure forces are involved. So these things can the questions can come on this particular laws, this Reynolds law, Euler's law, then have Faraday law, Weber's law, and Mach law. Mach law deals with the compressibility. Okay, and Weber's law when we have something relevant to surface tension. Here we have for grab forces. Euler law deals with the pressure, and Reynolds law deals with the viscosity. So you have to deal with the what we say that we called as what we say that the relation between this model and the prototype. Okay, so model and prototype kind questions can come. Okay, so you have to prepare, and this is one of the very 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 easy technique and easy scoring and important one. Okay, now I think these are all the most important thing under comes under the basic fluid mechanics. Now moving forward to this airfoils and wing. Right now we will focus on this airfoils and wing. So mostly in this particular topic we must how you can prepare. First of all I will tell you have some more days and how you can brush up this particular topic, airfoils and you have wings. So first of all, basically in airfoils, thin airfoil theory, the you just have a look on the assumptions. What are the assumptions they have considered on the thin airfoil theory? What are the final expression that they have obtained? How the vortices are relevant with one another in the airfoils? How the chord line and camber line, right? Then next is how if an angle of attack is provided to you, how you can obtain the CL or slope of it. How you can find the CL. Either it is a symmetric or a cambered. Next, how you can find the moment. Okay, how you can find the moment. What is the aerodynamic center? What is the center of pressure? So such kind of comes can relate with this airfoil. Then next can come on the nomenclature. Every time they're asking one or the other question from the nomenclature. So basically remember this 4-digit series, 4, 5, 6 and 7. 7 they never ask. Even 6 also they have not asked, but at least remember the 4 to 5. Suppose they have given you 34012. They might ask, what do you understand by last two digit? Okay, so 0.012 thickness, or it's a maximum camber, or 0.12 camber of C, right? What do you understand? What do you understand by 2? What do you understand by 3? What is a 0? Each and every number signifies certain things, right? So you should know this nomenclature. Definitely one question will come. You may also expect like this 0012. What will be the lift? What will be the CL at zero angle of attack? So let's see how many of you can answer for it. This is a simple question. Like I have sure given you one airfoil like 0012, right? And in this 0012, where at zero angle of attack, what will be the CL? Let's see the chat box. How many of you can answer for this? What will be the CL? What will be the CL? Very good. I got one answer. So without wasting much time, we can carry forward to our next thing. So obviously at zero angle of attack, it's as it's a symmetric airfoil, it is going to be zero. Now the gate people always tries to make you confused. So if they give some different type of graph, right? They can confuse with different, like one is alpha versus C capital L. One is alpha versus C capital small l with alpha, and one is capital L. Here I'm talking about airfoil. Okay, so which of the following graph is going to be correct? Okay, so I'm giving the options A, B, C, and D. Which among these are going to be the correct one? So here I've given, so at your zero angle of attack, right? Which graph, if they ask you to pick through the graph, right? One is capital CL, one is small cl. Okay, now another question I got in the chat box. So I request other to answer for this one, like which curve will is going to be correct. If not, I will be guiding you. One more question in the chat box, that if a airfoil is turned upside down, how will the slope and the lift changes? So upside down. So for an symmetric, it doesn't make any difference, right? It does not make any difference. And if it is cambered, right? It depends, because cambered they will not ask in this way, because it as a cambered, the negative angle of attack it will going to vary. Okay, it's going to be vary, it's not going to ask. Now I got one answer C. Now let me tell you where you have gone wrong. If because all are CL, right? This, if you look to the observe B and C, when we discuss for the airfoil, right? For the airfoil, we write small l as to declare it is a 2D. When we define for the wing, we write capital L, right? A fine difference I have made it. A fine difference I have made it over here. So this is another tricks they play in gate, right? So do remember when to use capital CL and when to use small cl, right? A very simple question, right? It looks the option B and C looks quite unique, but the difference I made is here. This is I made small l. This I made capital L, right? Now, come moving forward to another very application based question, like they might ask, there is an glider. There is a glider which is flying at Mach number zero point 0.3, and you have to choose certain different airfoils for this glider. Options are Naka 0009, right? And lift produce will be produced around 35, right? Lift will be produced as 35 and Mach number is zero point 0.3. Which airfoil is going to be suitable? Naka 2403. Then C, Naka 2418. And D is Naka 24. 1 0. So there are some options. I some designer want to design a glider of which is flying at Mach point 0.3 and lift to drag produce around 35. So which is going to be the suitable choice of this airfoil? There may be some question which is on like application based. So which is going to be the right one? Which one is going to be the right one? I'm looking forward for your answer and response. D, B because D will thinner. Okay, any other answer if I might get? Okay, now okay, let me clarify this. So as it is a glider, right? And the glider means what? What is the purpose of it? It will float into the air for quite a long time, right? And the Mach number is very less, right? Very less. So always for a very low speed, the thickness to chord ratio has to be very high. That means close to 15 to 18 percentage of thickness. This is the one of the application based question you can say, right? So it should be within the 15 to 18%. So among this, the right answer is going to be your 8 C. I hope all of you are getting it. So now I would like to see some responses that are you feeling this session is quite effective? Are you learning something different? I would like to know something in the chat box. Are you learning something different which is making your some of the doubts clear where you might get some clarity about it? I'm waiting for the responses. Kishore, I hope I made you clear that why not the option B, right? I hope you're gaining some of the ideas that how to select it, what are the pathways that you must follow, right? Okay, thank you everyone. So now we will proceed to the next one. Is like okay. Now with combiningly, like there are some theorems are there like Kelvin theorem, then Helmholtz theorems, and likewise lot many things are there. So likewise you have to remember those theorems also. Now talking about airfoil, it will be not over if you not talk about this flow separation, and which is quite connected with the boundary layer. Okay, this is again a very very important topic, like how this flow separations are relate with the boundary layer. And boundary layer again have sub classifications like boundary layer thickness bound, then momentum boundary layer, then energy boundary layer, and what is the formula. Definitely one question you will get from this boundary layer. So again this is another very important topic. This is the boundary layer. This is another very important topic, the relation between the flow separation, right? So once the flow separation begins, right? Once the flow separation begins, actually it is we call as an adverse pressure gradient. We call as an adverse pressure gradient. That means the change in pressure with respect to some distance, it has to be very much high. It will be it will have a positive value, right? And which will leads, right, if the flow moves around there. So if I talk about this flow, it will leads to create a reverse flow. Okay. These are again a very important concepts and idea to take away from here. The boundary layer, then the basic boundary layer, whether it's a laminar boundary layer or whether it's a turbulent boundary layer. Okay. And if there is a thermal boundary layer, right? And how this laminar and thermal boundary layer related? There is one constant called Prandtl number, right? How this Prandtl number is related. So this thermal part we will see in the thermal part we will see in propulsion when we will discuss the propulsion thing, right? So today we can just have given you the overview of the boundary layer, and this is one of the common topic for both the aerodynamics and for your the propulsion one. This is one of the very 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 common topic for all of you, right? Now next we will have wing. Now wing, again as I've said, for an airfoil, you must remember the theorem, the assumptions, like Prandtl line theory. What are the assumptions? What is the output they are getting? How the circulation is related with the vorticity? How the circulation is related with the downwash, right? Downwash or downwash angle. How the circulations is or related with the CDI, that is induced drag. Okay, there is some derivational relations between them, how they're related with one another, how what is CDI. There is a very unique formula, pi EAR, right? So how we can reduce the induced drag? What are the major parameter? The major one of the parameter is a aspect ratio. What is aspect ratio? Right? There are certain formulas, AR equals to B square by S. So there may be small numericals where we you may need to use this thing to find out the alternative parameter. What is aspect ratio? Equals to B square by S. Fine. Then we have like coming about the practical or application based question, right? Now you are being asked to select the aspect ratio for fighter aircraft. We have certain options. Again, we will do some application based. We have some 2 to 4, 4 to 6, the 4 to 7 will keep, 7 to 12, and 12 to 19. We have four options. So choose the right option and just write in the chat box that which is going to be the right option according to you. Which is going to be the right option according to you. So, if you are asked to select for a fighter aircraft, and you are asked to select the aspect ratio, appropriate range of aspect ratio, what should be the appropriate range? The option A 2 to 4, B 4 to 7, C 7 to 12, and D 12 to 19. Okay, I want some more answers from the viewers. Okay. No B. Okay. Okay. Some more. There are a lot many people are there right now. Let's see. All right. No. Okay. Let's come back over here in this thing. The right answer is our A. So you are right first. Okay. Now I will come here with some reason that why this is the right answer. I will also discuss that why we call this as a right answer. Now, first and foremost is what will happen if the aspect ratio increases. So most of the fighter aircraft you might have seen that they used delta wing. No doubt there are different types of delta wing, but they use delta wing. Now, why? What's the purpose of having delta wing and very low aspect ratio? Aspect ratio. First of all, they need to maneuver. They need to increase the maneuvering capability, right? So they have the this aspect ratio means the B is directly proportional, right? That means if the aspect ratio is increases, span is also going to be high, right? So if it is high, so the wing length is also going to be high. That is that mean. But here, in case of fighter aircraft, the wing area with the wingspan length is not that high. The reason behind the main reason of the fighter is to increase the maneuvering capability or to have or undergo the aerobatic performances. Right? If they have a very huge wing, they cannot maneuver as flexibly they are supposed to do. And second is a speed. This majority of the fighter aircraft have they are more than Mach greater than 1 or even 2, I can say. Moreover, they are of supersonic speed. So if the fighter aircraft of supersonic speed and having very large wingspan, it will moreover cause a drag. And if it cause a drag and it cause obstructions, so it will cause a normal shock wave. From normal shock wave, it can cause a structural damage. So no point of having the structures, right? If it leads to structural damage, there's no point of it. So you're getting my points. So we don't need a large span, we need a feasible one. So this 2 to 4 serve the purpose for this. So remember one more thing, more the speed, less the span. If they ask the same question like missiles, so if you have a design a missile, what should be the aspect ratio? Has to be less than 1. Has to be less than 1. So sometimes even zero point 0.3. It ranges between 1 to zero point 0.3. Missiles, if you have seen rocket fiends, it just around less than 1 to 1.3. Okay, I hope you got the idea. Again, some applications on aspect ratio relevant to wing. So one of the gate question, they mostly prefer the applications. So this time, as IIT Kharagpur is making the paper, there are a lot many huge chances. We cannot confirm it, but there is chances to ask like application based. So let me know any other relevant questions on airfoils and wing. I hope you are getting this. Just write in the chat box. I hope people are able to hear me. Okay, fine. I got your responses. So I will move forward now. So now we have almost covered up this different types of this wing and airfoil. Now terms for the viscosity and compressibility. This is a very small and very important part. Talking about both shock wave, oblique shock wave, expansion and normal. So this all the shock wave based on the shape. Like uh like you have to understand that when the bow shock wave will occur, when the oblique shock wave will occur, when the expansion and the normal, right? So again, this is another very unique topic with relevant to propulsion. So we will catch up this topic when we are discussing for our propulsion. This is again a common topic for our propulsion. Now coming to the wind tunnel, already we have said this is again, they will not ask much questions from here. They will again ask hardly 2 marks, and problems already we have said that what kind of problems will be asked. Now how you can plan your study from this particular topic, there are a lot many testing equipments like scleron techniques, right? So what are the advantages, interferometer techniques, what how one testing equipment is advantages over another. So such kind of questions can come. And what are different type of wind tunnel technique, they might give you some figure. Last year they have given some figures, and they ask what this technique is, right? So you have to be careful with the what are the important components are there, what are the important components placed in the particular technique, how they relate with one another, what are the limitations of that particular technique. So mostly theoretical questions will come from this wind tunnel technique part. Okay, wind tunnel technique only, mostly theoretical questions will come. From viscous and compressible flow we will conduct, we'll have another session tomorrow, so where we will have this viscous flow and compressible flow, where we'll discuss about it. And airfoils and wings, already we have discussed the important things that you have to follow over here, right? So any other questions are welcome. You have any other, you want any particular suggestions, like tips and tricks, any other possible apart from what we have discussed? So that also we can discuss, so you can write on the Q and A session. Any questions? If you have no, then we can close this session. If you have no question, you can type no question, so we can wind up for this for today. Tomorrow we'll have another session for propulsion. So there we will discuss about all those things. All right. So I hope, please kindly give the feedback. Right? Is it okay for you guys? It's clear whatever the outlines which I have discussed. Okay. I hope that's all for today. Thank you, everyone. We can wind up the session here. Thank you. I'm still live. I hope whatever we have discussed, it was useful for everyone. We have discussed the basic fluids based on the syllabus. We have mostly covered the basic fluid mechanics, the important things, the possible questions. dimensional analysis, wing and airfoils and wings, the practical based question. And this part we will discuss in the next class, wind tunnel techniques, right? Okay then. Thank you everyone. So I'm signing off right now.